Welcome, ladies and gentlemen. So what I'd like to do is show you how to write the equation of a polynomial, or write the polynomial function given a set of zeros. So we're given the solutions, we're given the zeros, where the graph crosses the x-axis, and we need to write the polynomial function or the equation of the polynomial, whatever you're dealing in your textbook. But basically, we need to write the equation, right, or write the function of the polynomial. So the main important thing is the basic thing that you need to know is when we're taking a function and we're solving for the zeros, there's a kind of step-by-step process. So I'm going to treat these all as zeros of a function. But let's pretend I had a function f of x equals x squared minus x minus 6. Okay? And if I said, hey, find the zeros, well, first thing you always want to do is see if it's factorable. If not, then you have to use rational zero tests, synthetic division, and so forth. But let's pretend this is factorable. First thing you do, you set it equal to 0. Then you factor this. This factored is x minus 3 times x plus 2. Then you set each factor equal to 0 using the zero product property. And then you solve. And you say x equals 3 and x equals negative 2. Now, this is a quadratic, right? It's a polynomial, but it's a quadratic, and it's fairly simple. This is something that should be very familiar with you, and we did a lot of these in Algebra 2. Now, basically what I'm doing is I'm saying, hey, I'm giving you these. I want you to write this. OK? So for the first example, it's basically what I'm exactly given. But now all we're doing is we're going from, instead of going top to bottom, we're going from bottom to the top. So since these are my zeros, my roots, my solutions, I am going to set them equal to x. So I'm going to say x equals negative 1 and x equals 2. Then where did they come from? Well, we had them written as factors. So to write them equal to factors, we're going to set them equal to 0. So I'm going to add 1 to both sides and subtract 2 on both sides. Therefore, I have x plus 1 equals 0 and x minus 2 equals 0. Why did we have our factors set equal to 0? Because we applied the zero product property, meaning this factor times this factor equals 0, so you set them both equal to 0. So now these are both my factors. So now I can write x plus 1 times x minus 2 equals 0. Then what do we have? Well, we had our factors set equal to 0. Once we multiply these, they give us our function, and we replace 0 with f of x. So I'm actually going to rewrite this. So now all right, so now to multiply these, I'm going to apply a FOIL. So x times x is x squared. 1 times negative 2 is negative 2. 1 times x is a positive x. X times negative 2 is a negative 2x equals f of x. Now, I'm going to write the f of x in front. I'm going to combine my like terms, and I'm going to write my constant at the end. So my final function is x squared minus x minus 2. And that's my final answer. OK? So it's kind of a step-by-step process. I'm going to limit. I only did this for educational purposes. So now, basically, what I'm going to do is I'm going to do the same thing. Now, here we have a fraction. And a fraction is very good, because I didn't say this in my directions. But we want to write our polynomial with integer coefficients. We don't want to write it with fractional coefficients. So there's something very important about this. When we set these all equal to 0, x equals 0, x equals 2, and x equals 1/2. Right? First thing you do is you set all of your zero solutions roots equal to 0. Then you solve for 0. Well, to solve for 0, this is already set equal to 0, so that's done. Here, I subtract 2, so I have x minus 2 equals 0. The big mistake here that students will do is they'll subtract 1/2. Well, x minus 1/2 equals 0. If you're going to use that as if you're going to use that, then when you multiply that by the other ones, you're going to get fractions as your coefficients. So to replace that, when we need to set this equal to 0, what we're going to do is use inverse operations. I'm going to multiply by 2 on both sides. So therefore, I'm left with 2x equals 1. Then I'll subtract 1 on both sides. So I have 2x minus 1 equals 0. So now I take all of my factors, x times x minus 2 times 2x minus 1. And while they equal 0, to save some time, I'm just going to set them equal to our function. Because really, we set them up. We want to find our function. Now, when multiplying these, I would highly recommend multiplying your binomials first, then multiplying by your linear term. So again, This will be the last one I'll break apart. And then from now on, I'll start doing them a little bit quicker. So I have x times x is 2x squared. Negative 2 times 2 is a positive 2. Negative 2 times 2x is a negative 4x. X times negative 1 is a negative x. This becomes x times 2x squared. Negative 4x minus x is a negative 5x plus 2. Now we have to apply distributive property again. And see, by showing all my work, I had to rewrite this. So therefore, this actually equals, now when I apply distributive property, I get 2x cubed minus 5x squared plus 2x. So that is what my function equals. Or you could write it like this. F of x equals 2x cubed minus 5x squared plus 2x. I just didn't have room to write the 5x or the f of x, but you could write, that's how you should write it in as well. OK. So now let's go into one. So now we have 3 again. So again, same thing. Set them equal to 0. X equals 4. X equals negative 2. X equals 1. Again, set them equal to 0. I'll save myself some work here. Hopefully you all see how I got that. Then you set each factor, set them equal to 0. So I have x minus 4 times x plus 2. Dang it. Times x minus 1. Oh, I eliminated that one. That's why. OK. So now we have a binomial times binomial times a binomial. Ugh, not very fun, right? But that's OK. The best thing to be able to do here is to simply choose one and then multiply the third one. So I'm going to use FOIL for this one. And I'm going to kind of simplify this in my head. So therefore, I have x squared minus 4x plus 2x is going to be a minus a 2x. Negative 4 times 2 is a negative 8. So I multiply this one. I multiply the first two. And now I need to multiply by the third one. Now, whenever I multiply, when I'm multiplying a binomial times a binomial, I always like using FOIL. It's pretty basic, OK? But when I'm multiplying a binomial times a trinomial, I like to use the box method. And basically, the box method works like this. I make a box. This one has 2 terms, so I make 2 rows. Here has 3 terms, so I make 3 columns. So I do x squared minus 2x minus 8. And here I have x minus 1. So basically, when you multiply length times width, you're finding the area, right? So that's exactly what I'm going to do. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 8 is negative 8x. Now, x squared times negative 1 is negative 8x squared. Negative 2x times negative 1 is a positive 2x. Negative 1 times negative 8 is a positive 8. And what I like about the box method is that, one, it keeps everything organized in its little boxes, as well as it lets you know your like terms are on the diagonal. OK? So now I have f of x equals x cubed. Negative x squared minus 2x squared is a minus 3x squared. 2x minus 6x is a negative 6x plus 8. There you go. OK. So now let's go and do one more. Again, now I have a 0 and a fraction. But that's perfectly fine in this case. So let's go ahead and let's get on with it. So we have x equals 0. X equals negative 2/3. X equals negative 2. And x equals 3. Again, set them all equal to 0 now. This one's already set equal to 0. This one's going to be 3x equals negative 2. So that'd be 3x plus 2 equals 0. This one equals x plus 2 equals 0. And this is x minus 3 equals 0. Now, I would say it's easier to multiply these two by each other. Although really what I have is x times 3x plus 2 times x plus 2 times x minus 3. So in multiplying these out, I have x times 3x plus 2. This becomes x squared minus x minus 6. Then I'm going to do the same thing again. I'm going to use the box method, which I'm running out of space here. Let's do the box method up here. So I have 3x plus 2. And I have x squared minus x minus 6. X squared times 3x is 3x cubed. 3x times negative x is a negative 3x squared. 3x times negative 6 is negative 18x. X squared times 2 is a 2x squared. 2 times negative x is 2x. 2 times negative 6 is a negative 12. Notice my like terms. OK? So therefore, again, this equals my f of x. Well, let's write the f of x in front. So I'll still have x, and then times 3x cubed minus x squared minus 20x minus 12. Then I need to apply my last distributive property, which is basically just going to raise the power of every function. So I'll have f of x equals 3x to the fourth minus x cubed minus 20x squared minus 12x. Whew. So there you go, ladies and gentlemen. That is how you write the equation of a polynomial when given your zeros, or solutions, or roots. Thanks. Whew.